A junior analyst receives a question at 9 in the morning. By 9:15, there is already a polished memo on the screen. The structure is clean. The language sounds confident. The risks are listed. The recommendation is clear. A few years ago, producing something this finished might have taken most of the morning. Then the manager asks a different question. Why are those the three risks that matter most? The analyst hesitates. What would change the recommendation? Another hesitation. Which assumption is carrying most of the conclusion? The document still looks excellent, but the conversation has moved from output to judgment, and suddenly the difference matters. That difference may become one of the defining problems of early career work in an AI-rich workplace. A person can now produce mature-looking work before they have had enough chances to become independently mature in the work itself. That does not mean the output is fake. It does not mean AI is bad for learning. And it certainly does not mean that every tedious junior task should be preserved in the name of character building. It means something more precise. For a long time, early career work mixed two functions together. It produced something useful for the organization, and it also gave the beginner repeated exposure to the situations from which professional judgment could develop. Those two functions often arrived bundled inside the same assignment. AI can make the production function dramatically cheaper. The harder question is what happens to the developmental function. That is the real issue here. Not whether juniors should keep formatting slides by hand, not whether every first draft must be written without assistance, not whether the career ladder is dead. The question is which experiences still need to happen in some form. If a beginner is eventually expected to frame a problem, notice what is unusual, catch a plausible error, explain a trade-off, adapt to a new case, and take responsibility for a decision. The current labor market evidence gives good reason to ask that question, but not good reason to tell an apocalyptic story. Some recent data do show pressure in parts of the early career market. PwC's 2026 analysis of job advertisements reports that highly AI-exposed junior roles are much more likely to ask for skills traditionally associated with seniority. It also reports growth in a category it calls seniorized entry-level roles. That is interesting because it suggests that employers may be asking for higher-order capabilities earlier. But there is an important distinction hidden inside the phrase AI exposed. Exposure means that AI capabilities are relevant to parts of the work. It does not prove that a firm has adopted AI, that a task has been automated, or that a job has disappeared. A Stanford working paper released in 2026 provides another important signal. Using payroll data, the researchers report a 19% relative employment gap for 22 to 25-year-olds in AI-exposed occupations compared with less exposed peers through June 2026. The divergence appears mainly through weaker hiring. That number deserves care. It is not a 19% fall in young employment across the economy. It is not proof that AI caused the gap. The authors themselves describe the findings as early descriptive evidence, not a causal estimate. They also report no comparable gap among experienced workers and no evidence of widespread economy-wide displacement. Other evidence makes the picture even less uniform. Yale's Budget Lab reported in June 2026 that it did not yet see a clear aggregate AI labor market footprint. A spring survey from the National Association of Colleges and Employers projected an overall increase in hiring for the class of 2026, with large differences across industries. So the most defensible conclusion is not that entry-level work is disappearing everywhere. It is that the transition is uneven. Some exposed occupations show real pressure. Some employers are asking for more advanced capabilities earlier. Other sectors are still expanding graduate hiring, and job requirements, task changes, adoption, and displacement are not the same thing. That nuance matters because the apprenticeship problem can exist even without an economy-wide employment collapse. Suppose a company still hires the same number of junior people, but the work those juniors used to do has changed. Drafting is faster, research is faster, routine analysis is faster, first-pass coding is faster. Summaries, comparisons, formatting, and basic synthesis can all be compressed. The headcount might look stable while the experience inside the job changes substantially. And experience is where expertise comes from. not experience in the vague sense of simply spending more years at work. Research on expertise has long warned against treating tenure as a clean measure of capability. Expertise is domain specific, and the quality of practice, feedback, learning opportunities, and exposure matters enormously. 10 years of shallow repetition is not automatically better than 3 years of demanding, well supported practice. So when people say junior work builds judgment, that statement needs refinement. Some junior work builds judgment. Some junior work mostly builds patience. And some junior work builds almost nothing except familiarity with a process that probably should have been automated years ago. The developmental value is not in the manual effort itself. It is in what the person has to notice and process while doing the work. Consider two tasks that both look repetitive from the outside. The first is copying information from one system into another, correcting formatting, and renaming files according to a fixed convention. If the work contains almost no diagnosis, no meaningful variation, no feedback beyond whether the file was accepted, and no decision that transfers elsewhere, there may be little developmental loss when it is automated. The second task is reviewing a recurring set of customer problems. The junior person sees patterns, notices exceptions, tries an explanation, receives correction from someone more experienced, and eventually learns which small detail changes the recommended response. The activity may still look repetitive, but the repetition contains variation, feedback, and pattern recognition. Those are not the same kind of repetition. This distinction is useful because it moves the argument away from nostalgia. There is no virtue in preserving useless friction. A bad apprenticeship is not improved by making the apprentice do more low-value work. The better question is, what learning mechanism is inside this task? Is there an active attempt before the answer appears? Does the person have to diagnose something rather than merely accept something? Do they see mistakes and receive correction? Do they encounter enough variation to learn what matters and what does not? Do they understand the context around the task? Can they transfer the skill to a new situation? Do they gradually take responsibility for harder decisions? If the answer is no, automating the task may remove almost nothing of developmental value. If the answer is yes, automating the task may still be the right decision. But then the learning experience needs to be preserved or replaced deliberately. That word deliberately is important because traditional apprenticeship was often accidental. People learned because they happened to be near experienced colleagues. They learned because a draft came back covered in corrections. They learned because the first analysis was wrong and someone explained why. They learned because routine work exposed them to enough cases that unusual cases became visible. They learned because responsibility increased slowly, often without anyone naming the process as a curriculum. There was plenty of waste inside that system. There was also learning hidden inside the waste. AI makes it possible to remove the waste much faster than organizations have learned to identify the hidden learning. This is where the distinction between AI as a scaffold and AI as a substitute becomes useful. A scaffold helps a learner do more than they could do alone while keeping them inside the reasoning and feedback process. A substitute completes the work in a way that can remove the learner from that process. The same technology can do either. One of the strongest examples of the positive side comes from a peer-reviewed study of more than 5,000 customer support agents. Access to a generative AI assistant increased issues resolved per hour by 15% on average, with the largest gains among less experienced and lower-skilled workers. That finding alone would already challenge the idea that AI necessarily harms junior development. But the more interesting part came later. During AI outages, workers who had previously used the system still handled chats faster. The pattern was consistent with some learning persisting after the live suggestions disappeared, especially among workers who had engaged more with the suggestions and then observed how customers responded. In that setting, AI seems to have done more than produce answers. It exposed less experienced workers to useful patterns in real time, while the workers remained in contact with the customer, the result, and the consequences of the suggestion. That looks much more like a scaffold. Now compare it with a different kind of setting. A 2026 randomized programming preprint studied developers learning a new asynchronous Python library. Participants using AI assistants performed worse on later assessments of conceptual understanding, code reading, and debugging. The clearest learning cost appeared among participants who delegated the work more completely. That result should not be generalized too far. It is a preprint. It studied a specific programming learning task. It does not prove that AI desk skills programmers, much less that it desk skills every profession. But it is useful because it shows the opposite mechanism clearly enough to take seriously. If a tool turns an unfamiliar task into the acceptance of a finished answer, immediate performance can improve, while later independent understanding remains weak. The contrast between these two studies is more useful than choosing one and ignoring the other. In customer support, AI assistants gave novices access to useful patterns while keeping them exposed to the live interaction and its outcome. In the programming experiment, fuller delegation could bypass parts of the reasoning that the learner later needed to perform independently. The lesson is not AI helps learning or AI hurts learning. The lesson is that learning depends on the interaction design. This is also why a polished deliverable is becoming a weaker signal of competence. A polished deliverable tells you something important. The person, the tool, and the workflow together produced a good result. That matters. Organizations should care about results. But if the person will later be expected to work when the tool is wrong, when the situation is unfamiliar, when the prompt is incomplete, when the stakes are higher, or when a client asks a question that the generated document did not anticipate, then the organization also needs to know what the person can do outside the happy path. That is the gap between performance and competence. Performance asks, can this system produce an acceptable answer now? Competence asks, can this person recognize what matters, explain the answer, test it, adapt it, and know when not to trust it? AI can sometimes make performance mature faster than the person. That can be wonderful. It can also be dangerous if everyone mistakes the first for the second. There is a deeper problem here because verification is not a free human skill that appears automatically when execution becomes automated. A peer-reviewed experiment with 758 BCG consultants illustrates this well. The researchers gave consultants realistic tasks. On tasks inside the AI system's capability frontier, the tool improved performance. On a task outside that frontier, access to AI reduced correct performance. The phrase capability frontier simply means the uneven boundary between tasks where the system is helpful and tasks where it is not. The boundary is jagged because two tasks that look similar to a person may be very different for the model. This matters for apprenticeship because organizations often imagine a simple future division of labor. AI will do the routine execution and humans will supervise. But supervision sounds easier than it is. To supervise a model well, someone needs enough domain knowledge to notice when the answer is plausible but wrong, when a key variable is missing, when a source is weak, when a recommendation conflicts with context, or when the tool has crossed from a familiar pattern into an edge case. Those abilities are forms of expertise. If the experiences that used to build them disappear too early, an organization can create a strange loop. It automates basic work because humans should focus on judgment, then discovers that the humans had historically developed judgment, partly by doing and reviewing the basic work. That is the supervision paradox. The answer is not to send everyone back to manual work. It is to separate the parts of the old workflow that created learning from the parts that merely consume time. Imagine a junior developer joining a team that now uses AI heavily. There is no good reason to insist that every piece of boilerplate be typed manually. There may be no good reason to forbid the tool from searching documentation, generating a first test, or suggesting a routine implementation. But the learning design can still ask the developer to predict what a piece of code should do before running it. Explain why the architecture is structured a certain way, diagnose a failing test, compare two possible solutions, and periodically solve a related problem without assistance. That is not a validated universal protocol. It is an application of a broader principle: automate low learning value execution while preserving the parts that require active processing, explanation, diagnosis, and transfer. Now imagine a junior analyst. the analyst is asked to prepare a recommendation. AI can help summarize material, organize arguments, draft prose, and challenge assumptions. But before asking for a finished memo, the analyst might first have to frame the decision in a few sentences. What is actually being decided? Which variables matter most? What evidence could change the answer? And where the uncertainty sits. Then AI becomes part of the work rather than the replacement for the thinking that defines the work. During review, the manager does not only ask whether the memo looks good. The manager asks what the analyst accepted from the AI, what was rejected, what was independently checked, what would change under different facts, and where confidence is lowest. Again, the goal is not ritual difficulty. The goal is to make the reasoning visible enough for feedback to happen. This points to a practical shift for early career professionals. The first step is to define retained capabilities. A retained capability is something that still needs to exist in the person, even if AI usually helps with the task. For one role, that might be diagnosing why a model result is inconsistent with business reality. For another, it might be explaining the logic of a recommendation to a skeptical client. For another, it might be reading code well enough to catch a security problem or understand why a system failed. For another, it might be recognizing when a contract clause changes the economic meaning of an agreement. The point is not to retain every manual action. The point is to identify what still has to be understood, explained, evaluated, or owned. Once that is clear, AI use becomes easier to design. If the capability is not important to retain, delegate aggressively. If the capability is foundational, create some moments when the person has to attempt, explain, retrieve, or transfer it before the tool completes the work. That does not mean every task should begin with an unaided first attempt. For simple administration, that would be pointless. But for a foundational skill, a selective first attempt can create a useful learning signal. It forces the person to form a view before seeing a polished answer, which makes comparison and correction more meaningful. There is also a better way to ask AI for help when learning matters. Instead of always asking for completion, ask for critique. Ask for alternatives. Ask what assumption seems weakest. Ask for a test that could disconfirm the current view. Ask the tool to explain why one approach may fail. Ask for an edge case. Ask it to compare its answer with the learner's first attempt. These forms of interaction do not guarantee learning. There is no universally validated prompting recipe for expertise, but they keep the learner more cognitively involved than simply handing over the entire task. Another useful practice is an unaided transfer check. Transfer means being able to use what was learned in a new but related situation. It is one of the clearest ways to distinguish familiarity with an assisted workflow from underlying capability. If someone can produce an excellent result only when the same tool, prompt structure, and context are present, that may be perfectly acceptable for some work. But if the role requires independent judgment, it is worth testing whether the person can handle a different case without the same support. The test does not have to be theatrical. It can be small. A junior analyst might review a fresh case without AI and explain the 3 variables that matter most. A developer might debug a related failure unaided. A new manager might explain how they would handle a difficult conversation before asking AI to critique the plan. The purpose is not to prove purity. It is to find out whether the competence survives outside the assisted workflow. Error review matters for the same reason. In a manual apprenticeship, errors often created learning because someone had to confront the discrepancy between what they expected and what happened. AI can remove some errors before they become visible. That is good for output, but it can reduce the number of diagnostic moments available to the learner. AI can also create a new class of error, a plausible answer that is wrong in a way the novice does not know how to detect. So a useful learning practice is to keep a record of discrepancies. Where was the AI wrong? Where was the person wrong? What clue revealed the mistake? What principle should change next time? Which type of case deserves more caution? The value is not in collecting mistakes for their own sake. The value is in turning errors into structured feedback rather than allowing them to disappear into a corrected final document. For managers, the design problem is broader. The old question was often, which junior tasks can be automated? The better question is which junior experiences can disappear safely and which capabilities need another path to develop. That begins with a task audit, but not only a cost audit. Take a junior task and ask two questions. What does this task produce for the organization? What does this task teach the person doing it? If the production value is low and the learning value is low, automate it without nostalgia. If the production value is high and the learning value is low, automate it if the economics and risk justify it. If the learning value is high, automation can still be worthwhile, but the learning mechanism needs to be named before it vanishes. Maybe the task taught pattern recognition because the junior saw hundreds of cases. Then replace that exposure with curated case review and edge cases. Maybe it taught quality standards because every draft received close correction. Then use some of the time saved by AI to increase the speed and specificity of feedback. Maybe it taught context because juniors sat in meetings and saw how analysis connected to client decisions. Then preserve that context instead of turning juniors into isolated operators of tools. Maybe it taught responsibility because people gradually owned harder decisions. Then design progression around increasingly difficult judgment rather than around volume of completed manual work. This is where AI can improve apprenticeship rather than merely threaten it. A traditional manager has limited time. Good feedback is expensive. Experienced people cannot sit next to every beginner all day. If AI reduces low-value production work, some of that reclaimed capacity can be used to increase feedback density. That could mean faster review, more comparisons between novice and expert reasoning, more postmortems, more exposure to unusual cases, or more chances to practice before a real high-stakes decision arrives. The customer support study is a useful reminder that technology can distribute useful patterns to less experienced workers at scale. The mistake would be assuming that every interface automatically becomes a teacher. Teaching requires more than an answer. It requires attention, interpretation, feedback, and later application. Organizations may also need to rethink what progression looks like. Historically, promotion often followed a visible accumulation of completed work. A person handled more accounts, more reports, more code, more analyses, more client requests. Volume was imperfect, but it was easy to observe. As AI compresses execution, volume becomes harder to interpret. Someone can produce much more without necessarily encountering proportionally more learning. A better signal of development may be diagnostic ability and decision responsibility. What can the person notice now that they could not notice 6 months ago? Which errors can they catch without being told? Can they explain why a recommendation is appropriate rather than merely presented? Can they identify when a familiar rule should not apply? Can they handle a new case that does not resemble the training examples? Can they take responsibility for a decision and understand its downstream consequences? These are harder to measure than output volume, but they are closer to the qualities organizations mean when they say someone has judgment. There is another implication for managers that is easy to miss. If employers begin asking for traditionally senior skills earlier, changing the job description is not the same as creating the capability. Judgment cannot simply be pulled forward by declaration. A company can say that a new graduate should think strategically, manage stakeholders, challenge assumptions, and supervise AI output. But those expectations still depend on experience, practice, feedback, and context. The organization may be asking for the outcome of apprenticeship while removing some of the experiences that used to produce it. That does not mean the expectation is unreasonable. It means development has to become more explicit. A stronger onboarding path might begin with modeling. An experienced person shows how a problem is framed, not just what the finished answer looks like. The junior sees what gets noticed first, which information is ignored, which uncertainty matters, and why one apparently attractive answer is rejected. Then comes guided practice. The junior makes part of the decision and receives specific feedback. AI can be present, but the review still makes the person's reasoning visible. Then responsibility expands. The person handles harder cases, encounters more variation, and has to explain decisions under changing conditions. At intervals, there are independent checks to see whether the capability survives without the usual support. This sequence is not a universal program validated for every profession. It is a design principle drawn from what is known about workplace learning. People need active processing, practice, feedback, application, transfer, opportunity, and support. The principle also changes how managers use the time that AI saves. There are at least two possible uses for a faster workflow. One is simply more throughput. If a team can produce twice as many drafts, it produces twice as many drafts. That may be commercially rational, but some of the saved capacity can also be invested in learning density. A 10-minute expert comparison may teach more than another hour of mechanical formatting. A short review of why a recommendation failed may teach more than repeating the same task 5 more times without feedback. A carefully chosen edge case may reveal more about judgment than a large batch of easy cases. The important point is not that every saved minute should become training. It is that efficiency and development are separate choices. Faster production does not automatically create better apprenticeship. If development matters, some part of the gain has to be allocated intentionally. This also helps resolve a common frustration for early career professionals. AI can create a strange experience where the standard of visible output rises faster than the opportunity to understand what is happening underneath. A beginner may be expected to deliver work that looks senior while still having beginner-level access to context. In that environment, asking for more context is not a request to preserve old-fashioned hand-holding. It is often a request for the information that makes judgment possible. What decision does this analysis support? Who will use it? What would make the answer unacceptable? Which risks matter most here? What does an experienced person notice that a newcomer might miss? Those questions move learning beyond the task itself. They connect an action to its consequences. That connection is especially important in work where the same surface task can mean different things in different contexts. A recommendation that is sensible for one client can be wrong for another. A code change that works in a test environment can create problems in production. A clause that looks routine can matter because of one unusual fact. A customer response that is normally appropriate can become harmful when the situation changes. Judgment is partly the ability to see which differences are meaningful. That ability grows through interpreted exposure, not through finished outputs alone. So the design target is not maximum independence from AI. It is calibrated independence, enough understanding to know what is being delegated, enough practice to verify the important parts, and enough context to recognize when the normal workflow no longer applies. There is an important counterargument to all of this. Perhaps the anxiety about apprenticeship is partly a romantic attachment to the old way of becoming competent. Maybe new professionals do not need the same path because the tools have changed. Calculators did not destroy mathematical thinking. Search engines did not eliminate expertise. Better software has removed countless manual steps from professional work without stopping people from learning. That objection is useful because it prevents a lazy conclusion. The aim should not be to preserve a historical sequence of tasks simply because previous generations went through it. The aim should be to preserve the capability. If a new tool can teach the capability faster, better, and with less waste, that is progress. If AI gives a beginner richer examples, faster correction, better simulation, more accessible explanation, and more chances to practice, then the new apprenticeship may be better than the old one. The customer support evidence suggests that this positive path is real in at least some settings. The concern begins only when improved output is treated as evidence that the underlying capability no longer needs to be developed. A second counterargument is that independent competence may matter less in the future because AI assistance will be constantly available. That may be true for some capabilities. There is no reason to insist that a person memorize information that can be retrieved reliably in seconds. There is no reason to preserve a manual step that adds no value once the tool is trusted and the error cost is low. But constant access to assistance does not eliminate the need for judgment in every domain. Systems fail. Context changes. Inputs are incomplete. Models cross uneven capability boundaries. Stakeholders ask unexpected questions. High-stakes decisions still require accountability. So the right amount of retained competence depends on the task. Error cost matters. How easy is the output to verify? How reversible is the mistake? How stable is the environment? How much domain context is needed to notice a bad answer? How available is expert review? How mature is the AI system on this particular task? A low-stakes, easy-to-check task can tolerate far more delegation than a high-stakes task where a plausible error may survive for months. This is why there cannot be one universal rule such as always use AI after a first attempt or never use AI while learning. The design has to follow the capability, the learner, and the consequences. For an early career professional, that creates a more demanding kind of agency. It is tempting to measure progress by visible output because output is immediate. The document is better. The code is faster. The analysis is cleaner. The inbox is under control. But learning is less visible. It appears later, when the tool is unavailable, when the case changes, when the answer is challenged, or when responsibility moves upward. So a useful career question is not only what can AI help produce, it is also what kind of professional is this workflow training someone to become. If the workflow repeatedly removes problem framing, diagnosis, error detection, explanation, and transfer, then those abilities should not be assumed to emerge somewhere else. If the workflow uses AI to expose the learner to better examples, stronger critique, faster feedback, and more varied practice, then automation may accelerate the development of those same abilities. That is the central distinction. The future of apprenticeship is not manual versus automated. It is accidental versus deliberate. The old model often relied on a messy mixture of useful repetition and pointless work. The new model has a chance to be more intentional. Automate the formatting, automate the transcription, automate the boilerplate, automate the routine lookup, automate any step whose disappearance does not weaken a capability worth retaining. Then spend some of the saved time on the experiences that actually build judgment. Make the learner frame the problem sometimes. Let them make an initial call sometimes. Show them the expert comparison. Expose them to the edge case. Review the mistake while it is still memorable. Ask for the reasoning, not only the deliverable. Test whether the skill transfers. Increase responsibility as competence becomes visible. And when AI is used, design the interaction so the person stays close enough to the reasoning and the consequences to keep learning. A career ladder does not have to preserve every old rung. But if a rung disappears, the developmental distance still has to be crossed somehow. That is the task now, not to protect junior work for its own sake, and not to treat faster output as proof that apprenticeship is obsolete. The goal is to make execution cheaper without making judgment accidental.